Good. So let's start with the official part of the event. First, we will be hearing about modeling decision making in circular economy. We all know that circular economy doesn't only start once we recycle products or once we are basically at the end of the life cycle of a product or of a service, but that it basically needs to start much earlier than that. That basically decision criteria, impacts need to be evaluated much earlier. So I'm really looking forward to welcome Sami to the stage to talk a little bit about that. And we agreed that later on there will also be a demo in the networking part if you would like to hear more about that.
Yeah.
So the stage is yours.
Thank you. And this thing, okay, this is working.
Yes.
Let's try this one. Okay. So, hello everyone. My name is Sami and I'm representing the VTT Technical Research Center of Finland here. And I was asked to tell you a little bit about, for 15 minutes worth, was it? About a new web service called Modeling Factory. I'm going to show you what that is and what it is good for and how to perhaps use it in design and decision making related to the circular economy. Circular economy, if I just start with that concept and how it is linked with the other stuff that I'm going to talk about, is certainly a very complicated and elusive concept, as everybody knows, and it's not going to be easy to bring it about. So it's, belongs to the class of the wicked problems. Somehow you have to get big enough a seed so that it doesn't collapse like a critical nucleus. And that's why it's not going to be easy to solve any of these problems in bringing it about just by technology. It's going to involve also a change in people's thinking and in the protocols and how we work together, basically. So I'm not trying to advertise here that this type of technology could, for example, solve everything, but I think that we can help to bring some tools into obtaining more high-quality decisions on every level of design. And by design, I mean, from, basically product design to policy design. And the way we are going to do this, we are going to offer a virtual platform where these different phases of design and decision making can be linked and where they can be aided based on using big data and simulation models and that sort of tools. So for the purposes of this talk, I've now defined the Modeling Factory as a web service where users can test and share their ideas on how to advance circular economy related design solutions. For example, what type of materials should be used, how they should be used energy efficient, in an energy efficient way, what type of ecological and economic consequences are there if we change something in the designs at some level. We are able to help in creating different types of computational models and solutions which then can be validated against high quality scientific, industrial and environmental data, basically. Our basic technology that this whole thing has been built on, we are now working on it in these EIT raw materials programs, but the basic technology construction started at VTT already maybe 12 years ago. So this has been a huge undertaking and technology is very mature. These more modern layers that we have now constructed in the recent couple of years are then somehow just making it more visible, something that has been hidden before. And that's called semantics, this technology that we are using. The Modeling Factory layer on top of this semantics technology basically acts both as a virtual working space, so it has all the tools that you need to do these model-based decisions, and it also involves tools by which you can make your designs and propositions visible to other users. Basically, you can make interactive web apps very easily from the different levels of these design models. and there are two types of use modes, open and private. So we are now basically in the process of privatizing, that was a bad word, making this commercial, this service. Basically, industries can use private workrooms for commercial activities, and that's what they are actually doing already. And non-commercial activities can also be undertaken in these open workrooms, and I will show you an example maybe later on after this talk, after the talks have been given. I can give a small demo to those who are interested in what type of open models you can find already there. And you can already, of course, Google just modeling factory and with two L's, by the way, and you should have it on the top of the list. There is also something else which has nothing to do with industrial modeling or this type of decision making, so don't gravitate to these Russian modeling agencies' web pages. Take this one. So this is basically illustration of what type of users we are serving and for whom we are preparing tools. So basically they are like three types of technical expertise that are needed for the usage. At the sort of ground level are the hardcore hackers, the developers who prepare the information infrastructure and write basically just code. In the second layer, so there are just a few of these, and number sort of increases when we go down of users. Then there is the modeling layer and the model makers. These could be some researchers in universities or research institutions, domain experts in firms or something like that. Somebody who makes the actual model. Then on the third level, there are the end users who can be different type of decision makers. They can be people who make product or engineering decisions, like product designers. They could be people who make economic decisions, like executives, and maybe even teachers who want to use some of these interactive web apps for teaching purposes. And this is a typical ladder of information, or somehow how we use it. In many cases, our modeling chain starts with some basic, physics, chemistry types of data banks and models, very heavy to compute, and somehow we have to make them fast enough and maybe just play with the output and sort of in the background produce the data. On the second layer, there will be process models where you manufacture something, or you design your CAD model for the new frame of the car or the battery or something like that. And then on the top level, there are the ecological, economic, and other footprint or impact assessment models. And these are sort of traditional, of course, science and engineering fields, but so that the fact that we can sort of now combine this layer is one novel thing, and also we can help somehow connecting the lower layers too. But these are difficult problems, and they, of course, contain lots and lots of challenges from mathematics to computer science, etc. So I'm not trying to trivialize this. I'm just saying that for many types of problems that we previously didn't have good tools for this type of layered model-based decision making, I think we have at least made some progress. This is our sort of like starting point, the engineering world, and I'm just showing you a glimpse of the technology that we are using, because, like I said, this is very mature stuff to give you an idea that we can basically now apply this to anything we want, and now we want to apply it to this type of decision making related to the design of the circular economy. But we started originally at VTT from these types of automation, engineering, etc. things. There can be some CAD models, 3D models of some factories, etc., etc. And somehow you would like to combine the data and the results and put them into some other types of like dynamic simulation models, for example. One typical design question is sort of like, yes, let's say that somebody has been able to design this with a CAD program. Can you somehow automatically transform this model in such a way that you could actually make the fluid flow in the pipes? And you could ask, not just are the pipes connected, CAD program layer answers that, but you could also see how much, I don't know, resistance there is to certain, pressurized fluid flow or things like that. So this is just to give you an idea of the basic thing. So to summarize somehow this basic technology level, we have been traditionally working with simulation and designs of computer-aided design systems. We have built tools for co-using these different simulations. So basically doing, passing information in a non-trivial way from one live simulation to another live simulation and chaining them up. There have been applications to control systems and various types of simulation environments, and also the semantics platform has included various types of team features and information management tools. So this is the stuff which is mature, and now we somehow bring it up and scale it up to include these even wider application areas. Just a few lines to summarize these points. It's Eclipse technology basically that we have underneath. The entire software, the semantics, has been published as an open source software, and it's maintained through a non-profit association, Teollisuuden hajautettu tiedonhallinta, THTH. You can Google that one as well. And we have a development consortium which has 15 member companies, SMEs and large companies as well. And new members are welcome. Just in case you are interested, you can contact me, for example, or go to the THTH web pages. Basically, the base technology project portfolio that we have used in development has been about 1 million per year throughout this recent years, and a little bit less before that. The most popular tools are, we have thousands of downloads, so we give out free of charge some of these tools that we made. But like I said, it's also possible to use the entire technology in a sort of secure, closed mode, and it's even more so in the future. Just some, different fields and type of simulation models that have been already combined there. There's a lot of stuff from different, paradigms, simulation paradigms, different simulation or coding languages, and application from CFD to system dynamics and Excel and automatic validation of models, etc., etc. And then an important remark for those who are interested in the IoT connection or the IoT world. We also have the possibility to directly link with automation systems and to discuss with sensor networks, for example, and use this type of input also in live models. So for example, it would be possible to, and I'm going to show a little example at the end, to somehow adjust your process in a factory dynamically based on the computation which is performed at the same time as you get live feed from the sensors. But, okay, all right. Two final technical slides. What makes this whole integration, how much do I have left? 5 minutes?
5 minutes.
All right, okay. So actually I'm coming to the example after these two slides, so I think we are good on time. So this is what makes this whole sort of magic possible. We put everything that we get, all the types of data inputs, all the models, all the user interfaces, everything, into this type of huge semantic graph. So underneath this entire technology is basically based on these types of ontological representations of data and the models, and that's what makes it somehow, from certain point onwards, faster to do integration work than with some more traditional methods. And that's why we also can automate a lot of things. Okay, so that's just a reminder of the importance of the ontology and the semantic graph method that we use here. Now, what I said was that because of these technological innovations, we are capable of performing deeper integration than just simple data integration or passing data files from one program to the other. We support various modeling paradigms, so all different level designers can basically use their own preferred tools. We can still communicate with, not with all of them, but we support connections, direct connections with many. And many languages can be used. So it doesn't matter if you use C++ or you use Python or you use some proprietary scripting, MATLAB or whatever. So we allow users to use their favorite tools in data production and analysis. Not all of them, but a fair amount of that, I would say. Not everything, though, should be integrated, right? There are many physical and science-based and IT technological reasons. So we concentrate in supporting different types of model families or paradigm families. And we enable then also the publication of the results from different layers to users as these interactive web apps. So the dissemination part is kind of very important part of this whole undertaking, so that we make visible now all this other technical stuff that we usually hide. So now I only have a couple of minutes, so this is good enough for presenting one concrete example. Where are we currently applying this, and where are we taking this whole thing? So how can we utilize the capabilities of Modeling Factory in bringing out some features in a more network operations of circular economy? So here is a typical assessment problem, now related to the life cycle assessment and footprint calculation. But these ecological things are becoming more and more important in all fields of production. So it's a good exercise. Basically, you collect contributions to the total footprint from many places when you produce anything. And by the way, this of course for the circular case should close somewhere, but it didn't fit in the picture, so it's left out. But the question is now, it would be important to understand for decision makers in individual firms and also maybe on a more coarse level, let's say legislators, for legislators, for example, where do the most important impacts come from, and if some changes are made in the production methods or materials or transportation means or whatever, what effect does it have on the whole? And also, still at the same time, individual players, it should be beneficial for them if they could see the effect just on their own. And we are using this type of data passing scheme to solve this problem, or try to solve this problem. And we are trying to set this up not for the entire universe, of course, but maybe for some restricted product chains or supply chains in a more restricted environment, but even that is non-trivial. But I'm hopeful that now we will get some, and there are already some applications where this exact thinking is being used. So there is commercial proof that this has hope in helping out. Basically, these are the different firms that want to somehow participate in some sort of circular economy operation, and in this case that's the footprint evaluation, and they all bring their data to this guy who we call the trusted operator, and this is the person now that is sort of constructing this entire simulation model for the footprint calculation for the entire network. And it is called trusted because, or model coordinator, because he can basically see the data that these people put in here, but the firms don't see each other's data, so that's like secure from you don't give your data to your enemy when you use the system. And this is what it sort of looks like in a little bit more schematic way. Those here are the firms or the operators, 1, 2, 3, and they have some sensitive data. Here is now the model described in this type of cloud here, which is built by this model operator using the Modeling Factory. What he will do now, after he has finished constructing the model based on the data given by the companies, is that this entire model can now be published as an interactive app to all these firms, and they can independently now, even without the help of the trusted operator who constructed the model, do computation and ask questions like, if I change something in my process, if I change this material A to B, what is going to be the effect on my own footprints or energy efficiency or anything like, or something like that, and what is going to be the overall aggregated result for the entire network. Because this is the way we would like the circular economy to work, that we get rid of the partial optimization, which of course always will be there, like we are just humans. And firms are, well, acting like humans too, but we would like to offer tools and for the firms and legislators, etc., so that they could see when something is really like against the advantage of the whole. And by this way, I hope that we will be able to do that. So I can stop here, and I have several examples there which I could show if there's any interest, but let's do that after all the talks are over. So thank you.
Perfect. Thanks a lot, Sami. Yes. Good. Maybe one question from my side before I open the floor for any questions that the audience might have. You said in the beginning there's a mindset shift needed, and I can imagine when you showed the picture of working across companies, working across industries. What is the biggest prohibitor at the moment for companies to adopt this, or what's the situation?
Do I get the mic?
Yeah, you do. Yeah.
Okay.
Yeah, that might help.
So I don't think I can answer in any generality in that, but some things we have noticed that, of course, I mean, everybody is very secretive because, well, you just don't want to give out your data, basically. And that's why one thing you have to try to do in constructing these types of tools, you have to try to also create some incentives for the firms to participate or to change their habits. And some of these innovations are very minor, but they might help. And I'm being cautious here because I know that this is a difficult problem. For example, the data collection, we have put some effort into that would be faster as it has been before, so we have new web-based tools for that. And the security promise is, of course, that's paramount, I would say. That's paramount if you can't give it, and we will have some, I guess, later presentations where these security and automated transactions kinds of things will be discussed in more detail, but all features of this type would be beneficial for our approach as well. We have concentrated on more traditional, let's say, ways of implementing these security things. For example, the model coordinator, of course, you could still, say that, okay, this guy might be the problem. If you don't trust him, then, you can't do basically any of that stuff that I said. But it's the same issue with, banking and banks, etc., right? You have to be able to build some sort of trust network. And I think this is, again, one of those things that, you have to learn a new work mode and maybe building trust networks, not just for money transfer, but, different type of design data transfer as well. So, and these technologies that we will hear later on will also help in that, but I think we need all of these different approaches to somehow bring this about. Yeah.
All right. Any questions from the audience before we move on? Okay.
All right. Thanks.
Thank you.